Welcome to aminacademy.com. In physics, let us discuss about escape velocity. Escape velocity or escape speed is the minimum speed needed for a free non-propelled object to escape from the gravitational influence of primary body, thus reaching an infinite distance from it. It is typically stated as an ideal speed, ignoring atmospheric frictions. Although the term escape velocity is common, it is more accurately described as a speed than velocity because it is independent of direction. The escape speed is independent of the mass of the escaping object but increases with the mass of the primary body. It decreases with the distance from the primary body, thus taking into account how far the object has already traveled. Its calculation at a given distance means that no acceleration is further needed for the object to escape. It will slow down as it travels due to massive body's gravity, but it will never quite slow to a stop. On the other hand, the object already to escape speed needs slowing negative acceleration for it to be captured by the gravitational influence of the body. Now let us derive escape velocity formula. When a stone is thrown, for example, when a stone is thrown from the ground, it goes into sky and falls back on the ground. Using machines, the stones can be thrown at much higher speed. A question then comes to the mind is, with how much velocity must a person throw a stone in the sky such that it beats the gravitational pull and goes out of the earth into space? This is idea behind the escape velocity term that is used when people talk about outer space and the missions that go for space explorations. It is essential to study the concept behind this term to appreciate and understand how much force and effort are put into design these missions. Let's look into these concepts in detail. Furthermore, escape velocity we can discuss more. For the objects into have velocity such that they are able to escape the gravitational pull of the earth and can go into space, one must take into account how gravity acts on the object and does work on them. Due to this work, the kinetic energy of the object decreases and gets converted into potential energy. This decrease in kinetic energy causes the object to stop and fall back down onto the Earth's surface. The principle of conservation of energy comes to our rescue into this case. Let's say that the object is taken from the Earth and reaches beyond its gravitational field, and its velocity at that point is Vf. The energy of the object is considered to be a sum of potential and kinetic energy. Let W1 denotes the gravitational potential energy of the object at infinity. Thus, the total energy of the object at infinity becomes, like here, look at this here. This suppose it's to be the mass body is Earth. Here, an object at is in position P, then it moves further dx distance. Let O be the center of the planet. The kinetic energy equal to half mv square. The force of gravity, we know that F equal to g m into m by x square. Here x is the distance between the center of the mass body to that body to escape, that is distance x, and capital M is mass of the big body and m is the mass of that another body. So F equal to gmm by x square. Now the work done, we know that force into distance, that is dw equal to f dx is gmm by x square dx. Integrating this expression to the limits r to infinity, that is integral r to infinity dw equal to integral r to infinity gmm by x square dx. Here gmm is a constant, take out, and x squared go up is x power minus 2, integrating is x power minus 1 over minus 1, r to infinity, give the values r to infinity limits value. Here we'll get minus g mm into 1 over x r to infinity, which is equal minus g mm 1 by infinity, because we are substituting x value here, and 1 by r. Now 1 by infinity, mostly it is 0, so we have minus minus plus, therefore w equal g mm by r. This is work done required to that body at the point P to the position Q. That means total work done from center to that point Q. Now, next, kinetic energy is equal to work done. Kinetic, that means that kinetic energy is fully converted to work done is converted to kinetic energy. That is half mv. Suppose v is square velocity, escape velocity ve. That square equal g mm by r. That is equating kinetic energy and work done. So from that we are getting v equal, cross multiplying and take square root, that is 2 gm over r. Now we know that g, gravitational constant, is gm by r, where g is a universal gravity constant, the mass of the body and radius of that body, gm by r. We are substituting g values, that means gm is gr squared, we are substituting here. Then therefore ve equals square root of 2gr. This is a escape velocity formula. Now for the earth we are substituting the values for g and r. G 2 into 9.81 for g, and r is 6371 into 10 raised to 3. That is 6371 kilometer, in converted to meter is 10 to the power of 3. So by calculating it gives 1180.3 meter per second. Convert to kilometer is divided by 1000 is 11.2 kilometer per second approximately. Therefore, the escape velocity of the earth is 11.2 kilometer per second. Now here this is escape velocity minimum is 11.2 kilometer per second. That means any body should be thrown from the earth at the velocity, higher velocity of 11.2 kilometer per second, then the body will not come back to the earth. That is the escape velocity of the earth. Now let us do some example problem regarding escape velocity. Calculate escape velocity from the moon, assuming that the moon is uniform sphere with a radius of 1.76 in 10 to the power of 6 meter and mass is 7.36 into 10 to the power of 27 kg. G value is equal universal gravity constant, G equal 6.67 and into 10 power minus 11. Newton meter square kg power minus 2. Now first write the given things, that r equal 1.76 in 10 raised to 6 meter, that is radius of the moon. Mass of the moon is 7.36 in 10 raised to 22. Not 22, this let it be this 22 kg. Then and v equal to gm over r, that is 2 into 6.67 into 10 raised to minus 11 into 7 into 3.6 into 10 raised to 22. Now here the 10 powers are collected and written as 10 power 5. Here the v equal to square root of 2 into 6.67 into 7.36 divided by 1.76 into 10 raised to 5. Now By using the calculator, we get V equal 2361 meter per second, converted as kilometer per second is 2.362 kilometer per second. So far we have done the problems regarding escape velocity and derivation of escape velocity and explanation of that escape velocity. We have done. Please subscribe our YouTube channel.